Brian here from Quant Labs Central. I don't know. Well, we are at a real interesting crossroads. Yeah, really interesting. Here's what we've got. We've got a C++, variety of little applications, programs that demo. Redis, really cool. R with RCPP and R inside, really good. And lately this new multi-threading library, open source, everything's open source, called FastFlow. Really good, but the really good from FastFlow has thrown me off with a new version of 2.0. I say that because there's so many options now of how to implement a high-frequency trading platform. It's confusing which way to go. I know where I should be going, and that is C++, 100% using CUDA. When you look at scalability, all these languages, all these tools can do it. The hardware side, to get on a server, a dedicated server, is very expensive. I've gone from $4,000 to $24,000 a piece with the $24,000 one at having about, it's a fairly new system from Dell, at 1 terabyte on board. So that's pretty pricey. I'm just a little guy. You can see where I'm from. I'm not, you know, no Lamborghinis parked out back or out front. I don't have trophy wives or girlfriends, so I don't support that lifestyle. Hey, I'd like to, but it's just not there yet. So as a result, I got to start from basically nothing, and I think from what I gather with other members and visitors, it's the same. So I always have to keep cost in mind. So what I'm looking at is probably the Tesla NVIDIA cards are a way to go, just for the sheer fact of the number of cores that they bring to the table and the processing power that they have. And not only that, but I mean the modern high frequency trading platforms also use the same technology. They're not playing with the, you know, the little racks of servers anymore and, you know, putting processes on these servers. What they're doing is they're putting boxes in there with these FPGA cards, and one CPU or one server could have probably 4 or 6 of these cards, and each of these cards can have anywhere from 500 cores to 1,000 cores each. So you can imagine when you do the math, you could have a system of 5,000–6,000 cores in it, plus the motherboard, plus the RAM, so it can get very high speed, and your trading platform can take full advantage of it. So you want to make sure you architect it the right way if you decide to go that route. From a cost point of view, from a savings point of view, this is the way to go. Not only that, but because you get the extra horsepower. The dilemma is is the options that I've looked at over the last number of years. You have MATLAB with the MATLAB coder, which is very powerful, but again, you're looking at just the coder itself, that toolbox is $6,000. On top of, you've got the distributed computing for the parallelization with the workers. That's going to run you up into tens of thousands of dollars, as well as the toolbox that enables you to use FPGA. Those toolboxes give you the advantage of having the ability to easily develop and have a very quick workflow on your platform and your strategies and your models. But again, I'm not a bank, I'm not a hedge fund, so I don't have that luxury of an expense. Even if I did, I put it towards capital and trading. The other thing is that when you look at R, and R is a great option to replace MATLAB, but there comes a time where you got R and you got C++. I've been able to bridge the two, obviously, through the demo videos I've done with RCPP, R inside. It works great. Honestly, it's a great way to bridge the two worlds. Now the dilemma is that when you want to factor in CUDA or whatever GPU or FPGA option you want to play with, Where do you call it from? Do you call it from the R, or do you call it from the C++? Obviously, if you're a seasoned person, you call it from the C++ side. But then how do you take advantage of the CUDA API? Because now all your math calls you have to use with that CUDA API, and not use the original envision of being able to call your R scripts from C++ and then pass them over to CUDA. You can't do that. So as a result, what I'm seeing is you develop and you prototype your models, your strategies within R, or even MATLAB if you want, and then you recode them for C++ and specifically for FPGA when it comes to high processing power. Because I've looked at all the little retail type of platforms, if it's MetaTrader, if it's Ninja, TradeStation. If you're a little guy, that's cool. I work with a lot of people that are starting up their own hedge funds, their own from banks or pop shops, and they're working with capital in the millions. So I have to consider these people when I'm developing this type of platform. So that's my core group, or my target group that this platform is being designed for. Obviously I'll use it for myself. I mean, it doesn't take much to cough up $1,000 or $2,000 for these processor or for these GPU cards, the Tesla boards. But I'd rather, again, spend that kind of money on a Tesla board than a server. Okay, and just get more bang for your buck. So, as I said, from an architecture point of view, on this type of platform, an HFT platform, my end goal is to get an FPGA-like or GPU-like platform. But then that comes back to your strategies and your models. How do they get coded up? So I'm now going back again. I'm always going back. Everything's all full circle, where everything is prototyped within something like an R or MATLAB, and then goes through a process of being recoded into the platform, the production platform, the execution platform. There's a lot of work still to be done, but what needs to be understood about this whole process, where a lot of people are going, gee, Brian, you're really not really with it because you're going back and forth and you don't know where you're going. The problem is how I'm doing it is, this is a journey for me. I'm coming from virtually next to nothing knowledge base of building models and strategies for trading, as well as being able to implement them into a live trading environment or a production environment. I've talked to a lot of HFT type of shops, and this is the route that they go, this is the route that they're at, and this is the end game. There's no more fancy, unless you go into things like neural trading or neural net and all that stuff. But I don't see myself doing that. I'm like about a pure quant mathy kind of guy. So that's where that stands. So I do know I want it to be C++. I do know I want, now that I've understood how the parallelization works with the multi-threading libraries, from TBB to OpenMPI to all the other ones, Silk or whatever else is out there. The one I like a lot is the fast flow. That thing's amazing, and it has a CUDA support. So those guys have done a bang up job. As well as I've also done so many tests with the Redis versus whatever traditional DBMSs are out there, databases, or other NoSQL options, and I still think Redis is the way. So in terms of persistence and data management or tick management, it's still going to reside in the Redis, so that is not time wasted. As well as the FPGA stuff with the parallelization, that is still being pursued. The problem is how do you implement your strategies and the workflow of the strategies from R into C++. So the hard part now is recoding them, unfortunately hand coding them from R into C++. there's a tool out there that I know of that I have access to. I've got no problem with it, but part of me always says I like to know what's under the hood, black boxes and all that. I don't know what to say. I'm just kind of lost for words on that. But the tools that are out there that do these jobs, not saying they're good or bad, that's just how I work it, and that's how I do my way of development, I guess. So, in essence, this is where we're at. Again, C++ with the CUDA support, looking like to be with FastFlow now. Very, very powerful multi-threading library with the Redis. Where does the R come in? That has yet to be determined. I do know that the strategies are very, very key for the whole thing. I just got to figure a way to generate the workflow from R into C++. I'd like to still see it somehow bridge it with the RCPP and R inside, but again, the end platform is going to be these CUDA. So that's where it looks very confusing, but it's always changing. This is why, as I said in other videos, I do things in small chunks so that I can test it, see how it works, research it, see the underlying code or the example code that is available. So therefore, I've got from end to end now, from the conception of strategies from the world of R, being able to transfer them into a live trading environment, into something like a CUDA or some GPU, but most likely it's going to be Tesla, or a form of Tesla using CUDA. That seems to be, again, I keep saying it, the standard. So that's where we sit. Enough looking at my ugly mug. Again, thanks for the support. You guys have been awesome. Thanks for the amazing questions. I'm here to serve thee. We are now entering, I keep saying, entering into the proprietary trading mode, as the strategies are going to be very important now, and that's where a lot of the work is going to be done, the algorithms. But the value is going to be in the C++, transferring them, or however you want to call it, from R into C++. Or, I'm not going to get into it. I always got a MATLAB as an option, and the MATLAB coders. So that, who knows, right? Over and out, and hopefully I'm not confusing you as it is. But what I say is not final until you start seeing something traded with live dollars. Just remember that, all right? Later, and thanks to all my members, thanks to all the visitors. The site's just booming like crazy now, and thanks for participating. I really appreciate it. Thanks from here, all right? Have a good night, day, whatever. See you.